How do you solve a system of equations by elimination? This is for task 2.8. Make sure this is the title that goes at the top of your notes, and then look up in your binder for the title name of this task 2.8. Okay, here's a reminder of how your notes should be set up. The title should be up at the top, and the task title should be at the top, and the title of the video should be on the side, and then you'll write notes in this column. Once you review your notes, then answer the question of the video title for your summary. Solving systems of equations. So far, we have solved systems using graphing and substitution. These notes show how to solve the system algebraically using elimination with multiplication and addition. Let's go to underline elimination. Elimination is easiest when the equations are in standard form. So standard form of equations, so this is a review, is ax plus by equals c. A, b, and c represent any real number. So I can make up a standard equation right now. I can make negative 5x plus 4y equals 19. There we go. I made up a standard equation. Notice how the x and y variables are on the same side, and then the constant, the number that's by itself, is on the right-hand side of the equal sign. In order to use elimination, you want to make sure that your equations are always in standard form. Okay, here are the steps to solving a system of equations by elimination using multiplication and addition. Go ahead and write down the steps 1 through 5, and I'll go ahead and review the steps as I complete the 2 examples for you. After the 2 examples, you'll also have 3 follow-up questions for you to try to come up with the answers on your own. We are going to solve the system using elimination. Here we have our system of equations, and we need a curly bracket there. So there's your curly bracket to demonstrate it's a system. Step 1 asks us to put the equation in standard form. And guess what? They already are. So step 1 is done for us. I always like when that happens. Step 2, determine which variable to eliminate. So either we're going to eliminate the x variables, which is why it's called elimination. We're going to eliminate the x variables, or we're going to eliminate the y variables. So take a guess. Which one do you think is easiest, the pink or the purple to eliminate? Well, since the y's have the same coefficient of 1, you remember there's an invisible 1 here and an invisible 1 here, and since one's positive and one's negative, if I add these 2 equations together, they're going to eliminate and become 0, and the y's are gone. So for step 3, we're going to use multiplication and then add the equations. Well, we don't have to use multiplication, remember, because the y's are already opposite. So I'm going to cross out that part. We're just going to have to use addition. And here we're adding the 2 equations. The y's have a 1 and a negative 1, so they become 0 and they eliminate. And then x plus 3x gives me 4x. And then I add 5 and 7 and I get 12. And now I have 4x equals 12. To solve for x, I divide both sides by 4, and x will equal 3. Make sure you replay this part of the video if you had difficulty understanding step 1, 2, and 3. So what I really like about elimination and substitution is that both processes have the same step 4 and 5, where you plug back in to find the other variable and check your solution. So here we found that x was going to equal 3 on the last slide. Let me go ahead and write my curly brackets. We found out that x was going to equal 3. So we plugged in 3 in for x here. And we get 3 plus y equals 5. Subtract 3 from both sides, and we get y equals 2. So our solution for this problem is 3, 2. X being 3, y being 2. And to check our solution, we will plug in x, the x's to be 3, and the y's to be 2, and make sure that they both check out, and they do right here. So I have a follow-up question. The solution is 3, 2. What do you think the answer would be if you solved using substitution? Think about that and write a response inside your notes. We are going to solve the system using elimination. Here's our system of equations. And our first step is to put the equations in standard form. So let's see if they are. Notice how the x and the y's are on the same side and the constant is on the right-hand side. Both equations are in standard form. Step 1 is done for us. Step 2, determine which variable to eliminate. Here we can do one of two things. We can eliminate the x variables, or we can eliminate the y variables. So which one do you think is easiest to eliminate? Remember, we're going to have to use multiplication, then addition. The last example, we had a positive y and negative y, so it was easy to find out which variables to eliminate. But now I have a positive 4x and a positive 4x, and one needs to be negative to eliminate, or I have a y and a negative 2y. So which one do you think? Well, if you pick the pink one, the x's, you're correct. We should eliminate the x variables. So what I'm going to do, let me erase this so I can show you what we can do. We're going to have to first use multiplication. Just a reminder, in the last example, we didn't have to use multiplication, but this one we do. So we're going to first use multiplication. We're going to multiply the first equation by -1. If I do that, I'll get a -4 right here, and that is going to cancel out with this positive 4 right here. I'm going to rewrite it down here in the green area. I have -4x minus, and then -1 times y. Here I'm distributing here, here, and here. -1 times y is -y equals 7 times -1, which is -7. And then I'm just going to rewrite my second equation because that's fine. I only need to multiply by 1 to one equation. Sometimes you may have to do it to 2, but just time is just 1. So now that I've used multiplication, now I need to use addition and add these two equations together. When I do that, -4x plus positive 4x is 0. Therefore, the x's eliminate just like what I wanted to happen. -y minus 2y is -3y. And this is going to equal -7 minus 2, which is -9. Divide both sides by -3, and y will equal +3. And I have the first part of my answer. If you had difficulty understanding step 1, 2, and 3, pause the video, rewind it, and rewatch this slide. Just a reminder, step 4 and 5 for solving a system using elimination is the same exact step for substitution. We found that y equaled 3, so we can use either the first equation or second equation to plug or substitute in 3 for y and solve for x. So here we do that. We're going to put 3 in for y here. Then I will subtract 3 from both sides, so I get 4x equals 1. Divide both sides by 4, and x will equal 1. My solution is 1, 3. X being 1, y being 3. To check this, I just need to plug in x to be 1 and y to be 3, and check to make sure that it equals 7 for the first equation, and it does. And then check, as I plug in x for 1 and y for 3, check to make sure that my answer is -2. And it is. Here is the first question of the 3 from the follow-up questions at the end of this video. Which step would eliminate a variable from this system of equation here? 3x plus y equals 4 and 3x plus 4y equals 6. So remember, go back through steps 1 through 5 and look to see which step we need to do. Here, first step says isolate y in the first equation. Should we isolate the y in the first equation? No, this is elimination, so there's no need to do that. And by the way, we're looking for the check marks. Number 2, add the two equations. Well, I could add the two equations, but it won't eliminate anything, so step 2 is not the way to go. Number 3, subtract the equations. I could do that, and that would work in this sense, but we don't subtract here. We always use multiplication, then addition. So subtracting won't work. And the fourth step is to multiply the first equation by -1. Well, yeah, that works. If I multiply the first equation by -1, and I'll distribute it here, here, and here, then I'll get -3x minus y equals -4. And the x's will eliminate. -3x will eliminate with +3x. So this step is the first step that we should begin with. Here's another follow-up question for you. What is the first step when solving with elimination? Should we add or subtract the equations? Nope, not yet. That is one of the steps, but you don't do that yet. Should you plug numbers into the equation? No. No, you shouldn't plug any numbers into the equation. Remember, that's when you want to check your answer, so you can't do that first. Do you want to solve for a variable? No, this is elimination. Remember, you want them in standard form, but you would solve for a variable in substitution. Would you check your answer? That's kind of silly. You can't check your answer first without using the process to get your answer. Should you determine which variable to eliminate? If you say that it is step 1, you are super close. You are super close. Because you will have to determine which variable to eliminate soon. And for number 6, should we put the equation in standard form? Yes, you should put the equation in standard form. And once you know that both equations are in standard form, then you can go to the next step, which would be this one here. Oops. Which would be step 5. And you would determine which variable to eliminate. Okay, here's the last follow-up question, and you're going to have to write down the information, pause the video, solve it on your own, and then play to get the correct answer. You're going to solve using elimination, and here's our system. Go back through steps 1 through 5. Double check them, use the 2 examples that we did previously, and figure out how you're going to solve the system by elimination. Once you have your final answer, play the video, and you'll see which answer is correct. So I'll assume that you paused and that you attempted this problem on your own. Is your solution 2, 2? No. Is it 9, 3? No, that didn't work. Is it 4, 5? Nope. If we checked our answers for these, they wouldn't work. So our last choice, and let's hope this is it. Yes. 5, 4 is your answer. And to check your answer, you'd plug in x to be 5 and y to be 4 and check to make sure it equaled -2. Then you would plug in 5 for x here and 4 for y here and check to make sure it equals 17. And it will, and that is our answer for this system of equations. Remember, this is also where the point of intersection, if I graph the 2 equations, and if I solve these 2 equations by substitution, I would get the same exact answer as 5, 4.